So E is just a number. That's all, just a plain old number, kind of like a cousin to pi. They are both irrational, which I'm sure you remember means they can't be expressed as fractions. And if you try to express them as decimals, well, the decimal value goes on forever and ever. Goes on and on without repeating. And you might get one number to repeat or even four numbers to repeat, but the whole thing doesn't repeat forever. Pi happens to be a little bit bigger than 3. Pi is, what, 3.14159? E happens to be a little bit less than 3. E is approximately 2.71828. But both of them go on forever, much, much longer decimals. Both of them also happen to crop up over and over again in mathematical studies. Pi, anything that's round. If we take the circumference and divide it by the diameter, it kept coming out to pi. That's 3.14. E keeps showing up in physics, in finance, in statistics, and in population growth. And that's its big deal. Growth. It's often called the natural growth factor. Because it kept showing up in natural situations. Now, E is usually the base, and we're going to be usually taking E to a power. E raised to some kind of power. Now, hopefully, there's an E to the X key on your calculator. If you could please look for the E to the X key. And I forgot to ask you to get your calculator. Please take a moment, pause, get a calculator, the best one you can. So often, some calculators have a plain old E key. I know the TI-84s do. But for most scientific calculators, the E to the X key is the second key on the LN button. So if you can find the LN button on your calculator, try to take the second of that. And hopefully it's going to come up E to the X. Now on some calculators, the E and then it will be blinking. It'll tell you to fill in what power. So give it a try, please. See if it will, like raise it to the first power. Does it come out to 2.718281828? My calculator won't go further than that. But I'm hoping your calculator will tell you 2.718281828, which looks like it's repeating, but the next digit is a 4, and then a 5, and then a 9. And that's as far as any of my calculators go. It will keep going on forever. These are rounded off values. You try to leave as much as you can in the calculator. We're not going to round it off to 2.7. I know we often round off pi to 3.14, but we should leave a longer value. We're going to leave as many places in the calculator as we can. At least anyway, up to 2.71828. In calculus, they want us to round our final answers off to the nearest thousandth, which means all the intermediate calculations have to be to more decimal places than that. Okay, if you found the e to the x key and got it to work for e to the first power, then take a moment now, please, and try e to the second power and e to the -1 power. Please take a moment, give it a... So my calculator gave me something like 7.3890561, which to the nearest thousandth, we could round off to approximately 7.389. Thousandth, you remember, is 3 decimal places. E to the -1, now when you remember, that just means 1 divided by e. But we can put it in the calculator as e to the -1 power. And e to the negative. So for e to the -1 power, my calculator gave me something like 0.36787794, which we could round off to about 0.368 if we're rounding to the nearest thousandth. The formula on the slide was used by Bernoulli, and he was trying to find compound interest. So his formula that E is approximately 1 plus 1 over n raised to the n as n approaches infinity, was he was trying to find what would be the value the more and more and more times we compounded this. More compoundings per year. Now, if this were a normal school year, we would have used his formula to discover E for ourselves. But this is not a normal school year yet. So we're just going to use Bernoulli's results to compound continuously.